Hello, this is William from Visual Components, and this is part one of the Basics of Working with Robots video tutorial. So in part one, you're going to learn how to move robots, create points and motions, use world and tool center point coordinates, that's world coordinate system and object coordinate system when working with robots, how to touch up points, that means modifying or changing a robot position in the 3D world, and how to define a robot's start position, such as joint initial position and joint zero positions. Alright, so let's get started. So before I show you how to move a robot, I'm going to show you how to select a robot in the 3D world and to work with its program. Let's go to the Webby catalog and go down to the robots folder. So let's go and add one robot, and let's add a second robot. Let's click fill to get a better view. Alright, so now if I want to work with a robot, I go to the Teach tab, and I need to select which robot I want to work with. I can either use the drop-down menu here, so I can select which robot in the 3D world to work with, or I can use the Programs filter, which is here. Then I can select the program icon in the 3D world. So I select this robot's icon, it's highlighted, I can work with it. I can also select this program icon here, and now I can work with this robot. Notice it's highlighted here in the Teach tab. Alright, so that's how you can select different robot programs, like so. Let's go and delete this robot here. Alright, and let's move on to the next section. So now I'm going to show you how to move a robot. You might also call this dancing with a robot, okay? So I have the robot selected in the Teach tab that I'm working with, and I can use these commands here in the jog section to move a robot. Jog joints, this is interacting with a robot's joints, so you can move it in the 3D world based on the joint's degrees of freedom, like so. Translate tool, this moves the robot about a tool center point, like so. So I have these coordinate axes I can use to move the robot, like this, and like this. Cool. And now I can use rotate tool. This basically is rotating that tool center point so the robot moves, like so, and reconfigures itself based on the rotation I apply. Alright, let's actually get a better view for you, like that. Alright, now when I am moving a robot in the 3D world, its joint values are being updated in its parameters. So if I go to the Param tab, you can notice I have the 6 joints of the robot here. So when I move the robot, alright, notice that some of its joint values do change as well, like so. I can even modify the joints as well, moving the robot by changing the joint values here in the Param tab. So I can actually just set the robot at its 0 position, like so. Alright, and that is also another way you can move a robot in the 3D world. Alright, let's go on to the next section. So now you know how to move a robot, let's go and create positions the robot can move to during a simulation. So I'm working with my robot. What I'll do is I'll use the translate tool command, and I'll move the robot over here. Now notice I'm working in the robot's main routine, which is its sequence here. Now if I want to create actions for the robot, I use the statements section here. So by creating a robot position, I can use a point-to-point motion statement or a linear motion statement. Let's create a point-to-point motion here. Notice I have a new action here in my statement grid. Let's move the robot over here, create another point. Alright. And let's go and move the robot over here and down a bit and create another position. So now I have 3 actions the robot to perform during a simulation. I can change the order however I want, like so. So when I click an action, the robot goes to that position, like that. Alright, now hey, I can't see anything. If you want to see a robot positions, what you can do is go down to the status bar and click this icon here. Alright, and this basically controls toggles for seeing the robot's bases, tools, and its positions. Alright, so now you can see I can see the positions I created here. I can even click it in the 3D world, and the robot goes to that positions. Let's go and turn the bases and tools off, like so. And let's actually turn the frames off. Alright, so now all I see is the robot positions that I created. So I can go to those positions however I want. Alright, so when I run the simulation, let's actually slow that down a bit for you. See, the robot goes to position 3, then to position 1, and then all the way to position 2. Yes. Now the order, notice here in the statement grid, it went to position 3 first, so if I want I can just change the order like this, drag and drop them into different locations, and the robot goes to that position 1, 2, then 3. Bam, like that. Now a linear motion, I'll go and create one here at that position. So one thing to notice is that in our software, you create points and motions when you create a linear or point-to-point motion statement. So if I want to access the properties of those motion statements, I can double-click it in the statement grid. You can notice I have the XYZ location of the position, as well as any rotational values, the configuration of the robot to get to that motion, as well as other properties. All right, so a motion statement is both a point and a motion. Okay, let's click close. So now if I go in position 0.4 there, run the simulation, robot goes there and there. So notice it was a linear motion from 0.2 to 0.4. All right, great. So now I'm going to show you how you can touch up points. So what I can do is I can select position 1 here in the statement grid. It's the currently selected position. I can use Translate Tool, and I can move the robot to a different location. And if I want the position to go here where the robot is, I can use the Touch Up command here, and the position goes to that location. If I apply any rotational values as well, let's actually move the robot like this. All right. Notice the configuration of the robot changed. I can touch up the point, and now its rotational values are updated as well. So when I access the properties, you can see I have the XYZ coordinates and the rotational values for the position as well. Notice these are all based on the world coordinate system. When you're creating robot positions, you can use the tool center point coordinate system by switching in the dynamic toolbar to object coordinate system. So the XYZ values are based on the current position of the tool center point at that time. Might be a little wordy, but I'll show you here. So right now I'm at 0, 0, 0 position. If I move the robot over here, notice the X value updates. If I create a position at the location and I access its properties, so right now 0.5, notice that I have world coordinate values. Okay? Close. All right, great. Let's go back to world. Now, there is another way. It's not recommended, though, when moving robot positions. So what I can do is I can select, let's do position 2 here. I actually can use the translate command in the function toolbar and move the position anywhere I want. All right, and that's where the robot position is. However, notice if I run the simulation, all right, the position is highlighted in red because the robot cannot reach it. Okay, so when moving a robot, creating positions and modifying those positions, make sure you do use one of the commands here in the Teach tab for jog joints to create positions, or the Translate or Rotate tool. Okay, and whichever coordinate system you're comfortable in using, you can use the world coordinate system or the tools coordinate system, which is also the object coordinate system, like so. Before moving on to the last section of the video, I want to briefly talk about other things in the Teach tab. So over here we have robot's bases and tools. You will learn more about bases and tools in other videos in this series. However, for now, know this is where you can select your bases and tools, translate and rotate, and do other things as well. External TCP relates to robots that use external tool center points. However, we will not discuss that in this video series. Configuration is a location of a robot's configurations. So for example, if I move a robot to this location and create a point, this is the current configuration I have for the robot to go to that location. I can toggle through the different configurations the robot has and how it gets to that location. If I want to change the configuration for the point, I can select it here. I can touch up the point. And now that is the configuration the robot has for going to that position. I can even access the motion statement's properties and change it in this property as well, like so. Different vendors, and I do want to stress this, different vendors have their own names for a robot's configurations, and we do respect that. So if you're working with a robot you're familiar with, you will see the names of the configurations as you would expect. Okay? Great. So let's go and reset the robot and go on to the next section. In the last section of this video, I'm going to talk about robot starting positions. These are also known as the robot's states. So when I run this simulation, the robot is starting from this position. So I run. Now when I reset the simulation, the robot goes back to that starting position. I can modify a robot's starting position by simply moving the robot to a location I like so. And I can click Run on the simulation player. Robot goes to that position. When I reset, the robot goes back to the position I had it at. Now another way to do this is, let's go and use jog joints. Bring the robot back over here. And if I want to save this as the robot's starting position, I can go to Simulation in the menu bar and click Save State. So now if I reset the simulation, notice the robot does not go back over here, it stays where I had it. So I run the program, reset, the robot is now at that starting position. Alright, pretty neat, huh? So another way to do this as well is if you make a mistake, you can go to the robot's parameters in the Param tab, and you can change the joint values however you need to. So if I want to make the robot in its joint 0 position, and I want to save this as a robot's starting position, I can use Simulation in the menu bar, Save State, or I can simply run the simulation. And when I reset, we're back where we began. Alright, so I hope this first part of the robot video series was helpful to you. If you have any more questions, visit our community at community.visualcomponents.net and look forward to the part 2 of this video series. Have a nice day.